Hi all, and welcome to the second episode about our series on SSI applications. In the previous episode, I talked about the cryptographic key vault. This is a tool to manage and generate keys in a very secure way. In this episode, I am going to talk about Webwallet, which provides a much more natural way of interacting with the key vault. So let's dive into it. As I said before, the Webwallet's main goal is to provide an easy-to-use interface to handle the cryptographic key vault. Because let's be honest, your users are never going to write lines of code in order to interact with the key vault. The user experience has to be as simple as possible. With this in mind, and with the fact that we want to open our technology as much as possible and prevent vendor lock-in, we designed the cryptographic key vault to follow specific standards. These standards ensure interoperability between different wallets so that you could design your own wallet or use another wallet that suits your needs more. So in a previous episode, I talked about two of these standards called the BIPs. And the first one is the BIP 39, which describes how a mnemonic, remember this mnemonic is this key phrase with 24 words, translates to a seed, to a 512-bit number. The BIP 32 then specifies how you can use this seed to generate individual keys. The problem here is that this tree-like structure that you can see on the picture can become complicated very quickly, and different wallets could implement this in a variety of ways. To limit this degree of freedom, there is one last BIP I want to talk about. I promise you it is actually the last one. So the BIP 44 specifies the key hierarchy. This means that it limits how a web wallet can derive these keys, and it does it in the following way. So on a slide, you can see the representation of a key in a path-like manner. So remember, in your file system, you have something that really looks like this, but this is actually a key. And at the root of this path, you find M, which is this master secret, this 512-bit number. And then it is followed by 44. 44 just means that the BIP 44 specification is followed. Next, you have the coin type. This is interesting because ideally you want one secret or one key vault for different assets and different funds. In order for this to work, you need some way of specifying which key belongs to which fund or which asset, and this is exactly what this account field's purpose is. Here, for example, you could specify that this key belongs to Bitcoin or Hydra or some other asset. Next, you have the account field. It helps to think of this as independent bookkeeping units. For each master secret, you can have 2 to the 31 accounts or user identities. And these are totally separated from each other. So imagine that you have a business account where you handle your day-to-day transactions, and each month you send some kind of amount to your savings account for later. Now, with this construction, you cannot access the funds from your savings account from your business account, so they are totally separated. The next field is a change field. This is not really important for our use case, and I will also not talk a lot about it. The only thing that I want to mention here is that if you're more interested in this, you should go and check out the BIP 44 specification. For now, it just suffices to know that it can either be a 0 or a 1. The next field is address index. This ensures that multiple keys can be tied to one business account so that you can use one key per transaction. One account has 2 to the 31 keys, so running out of keys is not an issue. So now that we saw the basic building blocks that are behind the key vault, let's see the user interface to this, which is actually the web wallet. For this, I invite you to go to wallet.iop.global, but you will also find a link in the description. Now that everybody made its way to the Hydra web wallet, you see here that you have two options. The first option is to create a new wallet. The second option is to access an already existing wallet. So I assume that you do not have an existing wallet, which is why we will create a new one, especially for you. Okay, here you see some security recommendations, but we're going to click on continue. Of course, you should read them, but for the sake of the demonstration, I'm going to skip them. And now the browser queries you for your password. This is this encryption key that I've been talking about, which encrypts your seed. Everything happens here locally in your browser, so you should not be afraid that we have your keys. And if you don't believe me, you should check our GitHub page because the Hydra web wallet is entirely open source. Actually, you should check it anyway because there is a lot of cool stuff there. Okay, so the password is now something very secure. And I'm going to generate it. So now the window pops up and I want to save the file for later. So let's have a look at how this Hydra wallet looks like. You can see here that it's actually a JSON object. It has an encrypted seed property, which contains a base 58 encoded seed. It also has plugins, but this is until now empty because as we initialize the vault, it does not have any state stored. Okay, so let's access the wallet. Here we have two options. The first one is key store file. So this is a file we downloaded before. And the second one is the mnemonic phrase. Our team is working hard on making all this happen, so expect this to arrive soon. Here you can go to the key store file. Let's open it. And now again, your browser needs your password so that it can decrypt the seed and recreate it in the wallet interface. Let's give it here to him. Let's unlock it. And now you see the dashboard. Here you see that the main account has currently a total balance of 0 test Hydra, but you can toggle here. And unfortunately also mainnet, there is 0 Hydra in this new account. And we can also see that there are wallets available. Here there is the address 0, which is pre-generated. And you can also, for example, create a new business account. Let's save it. And now you see that there are two. Here you have the options to copy it and send some funds from it, rename it, view it on a block explorer to see what kind of transactions happened with it. And you can also delete it. Okay, so now I want to recreate this inside the code so that you can see how similar it works. So let's see each other in part 2 of this series.